Okay, good morning, ladies and gentlemen. My topic for this morning will be, this is electronics, and this is with regards to the so-called study of rectification. One of the requirements on how to operate the digital circuits now is actually by using a reliable power supply. And that reliable power supply is the so-called, for like big screen TVs, it's the so-called switch mode power supply. I just want to simplify how to bring out the voltage of a switch mode power supply by just concentrating the concept on just one part of the portion of the circuit. So we could analyze on how to bring out the regulated power supply on a switch mode power supply. Okay, let's try to bring out the discussion. The topic is how to rectify alternating current. Our power source coming from the utility line is actually alternating current. And to utilize that alternating current for us to use it in digital circuits, we must have to convert that alternating current to direct current. So the topic for tonight is actually how to change alternating current to direct current. Alternating current to direct current. Alternating, we change it to direct current. Because all digital circuits now need direct current. And it should be the so-called regulated one. Like the power supply of computers, okay, those are all regulated. And the concept that I will be discussing will be the same on how to bring out those voltages. Okay, let's try to bring out the circuit of this one. The first requirement on how to bring out the direct current is actually we should have a power source. So we should have a transformer. This is a transformer. This is the primary side. This is the secondary side. Okay. So this portion of the circuit is actually alternating. This is the dangerous side. This is the safe side because the safe side is actually on the secondary side. Safe side meaning if we try to poke our testers over here, you are safer to poke your tester here on the secondary than on the primary. That's why, like what I said, this is secondary side, it is safe, it's on the safe side, and this is the primary side, this is the dangerous side. This is the high voltage side, this is the low voltage side. Okay, I will try to check myself. Okay, so the first requirement on how to bring out the direct current is we should have an alternating current source. This primary side here, the voltage coming in here is actually the voltage that came from the post, okay, supplied by the utility line. Okay, and this transformer, this should be a transformer which just a small one, in which we could use it to convert that AC voltage to a lesser AC voltage. So we could convert that lesser voltage to a direct current voltage. And of course, if there is a direct current voltage, there should be a direct current source. Okay, the next part of the circuit to convert alternating current to direct current is we should have a diode here. I will just discuss the simplest one, the so-called half-wave rectifier. Anyway, the concept is just the same for half-wave and full wave. It's just that in the full wave, for both alternations, okay, there will be an output. But for a half wave, there is only one alternation. The second alternation is 0. First alternation, second alternation, okay? So like the output is actually a pulsating DC. It's a wave, okay? Okay, let's try to bring out the concept on how to convert this alternating current to direct current. To convert this alternating current to direct current, okay, I will start with the primary side first. The primary side is with the higher voltage than the secondary. So if we try to bring out the graph will be this. And since the voltage or the transformer is actually a step down, of course the voltage on the secondary side should be less than the primary. So if we try to bring out the output or the graph of the alternating current, voltage and current, it is still sine wave. Okay, it's still sine wave, but the magnitude is smaller than the primary side. So the wave of the primary and secondary are the same. The only difference is that on the primary side, the magnitude is bigger, and on the secondary side, the magnitude is smaller. Okay, it is smaller because the voltage needed for digital circuits are actually in the range of 5 volts, 3 volts, 9 volts, 6 volts, something like that. So compare this 12 volt to this, if we are here in the USA, if this is 120, okay, and you just need a 12 volt, of course the the transformer should be stepped down, so we will step down the voltage from 120 to 12. So if this is 120, and it is a step down, what will come out on the secondary if you need 12 volts, so you should be 12 volts. It is lesser magnitude than the primary side. Okay, to rectify the alternating current here, I just use a half wave. When this graph on the secondary side will come out, okay, at that moment, this portion here will be plus. Okay, so current will be entering here. It will pass through the diode, right? It will go to the plus line, plus terminal. This is a DC output, so if it is a DC output, of course, there should be a load here. I will be placing a load here. Okay, RL. So like what I said, current coming here during the passive alternation, it will pass through the diode. It will go straight to the plus sign, the passive terminal. It will pass through the load. Okay, then go back to the negative terminal. This terminal here is with this designation minus. Since this is now DC portion, if this is plus, this should be minus, right? So the current coming here will enter the load. It will go to the negative terminal. Okay. Then it will go back here. You see it, guys? When the passive alternation come out, current will be coming here. It will pass through the diode. It will go to the plus terminal. It will pass through the load. It will go back to the negative terminal, then back here on the bottom portion. That's for the positive alternation. Okay? So when the current reverses direction, okay? When the current reverses direction, when this is now plus, and this will be minus, current will go pass here, okay, it will pass here, it will pass through the load, okay, it will pass through the positive terminal, go back here, okay, go back here, then it will try to enter the diode, okay, but during the negative alternation, like what I said, it will pass here, go here, pass through the load, it will go back to the positive terminal, go back here, but it could not enter the diode because the diode is only activated, okay, if the anode is positive with respect to the cathode. Okay, since this current here is against this diode here, this current during the negative alternation could not pass through the diode. If it could not pass through the diode, okay, it could not go back here, right? So it seems the circuit is actually off during the negative alternation for a half-wave rectifier. Okay, it will pass here, go here, pass through the load, it will go back to the positive terminal, it will go back here, it will now try to enter the diode, but since the diode is actually against this current here, this current could not pass through this diode here, because a diode will only pass current in one direction. It's only in this direction. Okay? So during the negative alternation, in which the current will be in this direction, it could not enter the diode. And since it could not enter the diode, okay, the circuit is not complete. It is not complete because the current had not gone back to this terminal because it was intercepted by this diode here. Because a diode will only pass current in one direction, on the positive direction. Because in the negative direction, it is against the polarity of the diode. Okay? So during the negative alternation, the current which is supposed to be going back here could not pass through the diode. And since it could not pass through the diode, okay, it seems this circuit is off during the negative alternation. That's why the current output during the negative alternation is actually this portion here. It is 0. You got it, guys? Okay, I will try to get my eraser. Okay, I will try to erase the second one. The second one, the negative alternation arrow. I will just maintain the positive arrow. Okay. On the next cycle, okay, the current will be again positive. This portion here. And during this time, again, this will be plus. And this will be minus. So the current will be again emanating from here. Okay, and since this current actually coincides with the open condition of the diode, okay, the current could pass through the diode, okay, it will follow this arrow here, then this arrow, it will pass through the positive terminal, again it will pass through the load, it will go back to the negative terminal, it will follow this arrow here, and follow this arrow, then back to the negative terminal. And that current is actually represented by this one here. Okay? And again, when the negative alternation again come out, this portion here, okay, this will be plus, and this will be minus, right? Like what I said a while ago, the currents will supposed to be will follow this path here, but upon reaching this portion, it could not enter the diode because the diode will only pass current in one direction coming from this. And since this direction in the negative alternation is actually the reverse of the conduction time of this diode, it could not pass through the diode. So for the negative alternation, it could not pass through the diode, so it seems the circuit is off. And during the time, there is no current output, and that time is actually represented by this one. Okay? This is minus, this is plus. That's for the two alternations, right? So if you try to notice the output, during the positive alternation, this will be the current output. During the negative alternation, the circuit is actually not complete. Okay? The current output is this one. Again, when the next thing will be a passive alternation again, this will again be the output current. And during the negative alternation, the current will again be zero. During the positive alternation, this will again be the current. Negative alternation, this will be the current, zero. Positive alternation, this will be the current, then so on. So as you try to see the graph, it is something like this. You see it, guys? This is the current output, and this is time. So for a 60 Hertz, these graph here are actually very big ones. So if your transformer is just only with the frequency of 60 Hertz, okay, you can hear a humming sound. And to eliminate that one, for switch mode power supply, we change now this transformer here to a so-called high frequency transformer. High frequency. Meaning to say, the frequency is now in the range of kilohertz to megahertz. So, if the frequency on the secondary side will be in the range kilohertz and megahertz, these pulsations will be very smooth. And it is actually smoother. It is smooth. You could not hear any humming sound. Okay? So, for switch mode power supply, okay, instead of using the so-called 60 Hertz transformer, we use the so-called high frequency transformer so that the pulsations of the output will be smoother. Okay? So, as you can see it for switch mode power supply, the graph of that one, if you try to see it on the oscilloscope, it will be smoother. Okay? It will be something like this, maybe smooth. Okay? If the pulsations are very minute, the current will be smoother and the operation of the digital circuits will be better. Okay? So, to bring out a good DC voltage for switch mode power supply, instead of just using 60 Hz frequency transformer, we use the so-called HF high frequency transformer. So if you try to inspect a switch mode power supply, there are so many high frequency transformers on the secondary side, and each transformer got a different frequency, so that if you try to rectify those voltages, okay, of course the pulsations will be very small. And to help smoothen out the output of the pulsating DC, we use a so-called capital letter C here. I place here capital letter C. This will be electrolytic capacitors. used to smoothen out the output voltage. Okay? Instead of a very big pulsations like that, if the frequency is very high, these pulsations, if you try to see it on the oscilloscope, it will be the pulsations will be very negligible to the human eye. So it seems it's almost a perfect DC. Okay, because the pulsations will be very small like that. Okay, it's better for the digital circuit to operate. So one of the requirements for us to smoothen out the pulsation is actually to use a high frequency transformer. Okay, and as an additional thing, we will connect a big capacitor here, an electrolytic capacitor, okay, to smoothen out the pulsations to an almost perfect horizontal line. So that's the use of the so-called capital letter C here. And for this small letter C is actually to filter out noise. Just in case there is noise, this small capacitor is actually in the range nanofarad or microfarad, or picofarad, nanofarad and picofarad. Those are actually the capacitors that will try to eliminate the noise coming from the output of the secondary line. So for the big capacitor, it will try to smoothen out the pulsations, and for this small capacitor, okay, it will try to eliminate the noise coming from the secondary line. Okay, that's how to rectify alternating current to a direct current. Okay, I just indicated here a switch, what you call this, a single or half wave. Anyway, the operation is just the same. I just discussed how the current passes through the diode to obtain a pulsating DC. I will try to repeat it during the positive alternation. The current will be in this direction here. It goes back here. During the negative alternation, the current will try to move like this, but it could not complete the circuit because the diode is actually obstructing the flow of current in the reverse direction, because diode is supposed to pass only current in one direction. So during the negative alternation, okay, the negative current is cut off by this diode because it is reverse bias. Okay, it is against the polarity of this diode here, because this diode here will only pass current in this direction, not in this direction. And again, as the alternation alternates, when this is plus, it could pass through this diode here, so it will try to complete the circuit. Okay, those are only the two alternations required to bring out a pulsating direct current. Positive alternation, negative alternation, nothing, because it was obstructed, or what they call this, blocked by this diode, because this diode only pass current in one direction. Okay, that's it, guys. That's how to rectify alternating current to bring out a direct current needed by digital circuits. Good evening from Los Angeles. This is Professor David J. Dilsrich.